Okay, so I didn't want to bore you with too much detail, I figured that the best thing to do is to show the important things rather than, you know, show me putting capacitors, soldering them into a board and taking the old ones out. Anyway, so this is what I've done so far. So I'm going to explain it now. Okay, so basically all these capacitors that you see here were on the board. Oh, they're rolled about, as you see in this little picture. And that's that baby there, the snap-in capacitor. So basically what's going on here is this is a power supply from the CLD-310 machine that we showed in the previous video, where we took the laser assembly out of it. And I decided to investigate this power supply to see what was gone, what was broken, and where the fault might be. So I actually tested this capacitor here first. I don't know why, but I actually went to that one first, and it was as dry as Gandhi's flip-flop, as somebody else would have said. But that was totally dry, totally dead. So that's that one there, and I took it out. It's brown one. So there's actually 3 of them on the board. There's 2 more. Okay, they were actually all right. And there was another one here that I found faulty, which was this one here. Okay, this one here was also faulty. I also discovered one under here. I was kind of coming around and going, oh look, there's one under there. So I took that as well. So I took out every single capacitor. They're the most common failure on any power supply board, simply because these capacitors have basically got liquid in them, and the liquid dries out. So as the liquid dries out over time, they become dry, and then they become, you know, less capable of capacitance. So basically I took them all out. So using a desoldering gun, I went around the back of the board, and if you've ever seen the soldering gun here on YouTube, just look it up. The soldering gun, they basically have a little vacuum on them. You press it into the board, you press it into these little fellas hard, and it literally just sucks the flux out, sucks the solder out. Okay, so it works quite well. Some of these, this is, you know, old leaded solder, so I had trouble with some of them. So I got my soldering iron and just basically lightly heated them a bit more, sucked it again, and most of them came out of the board, no problem at all. Wasn't any great issue. Ones that gave some trouble were the likes of these big. This big one here. This one here was actually very easy. I literally just heated the bottom of that and out it came. That's actually been replaced. I've replaced this one already. So that's my soldering technique there. So not bad for somebody who hasn't soldered in a long time. Little side note, actually, I remember in a job interview, and the man asked me could I solder, and I said yes I could, and he said, oh my god, I can't believe you can solder, you've got the job. So you should learn to solder, because you could get a job out of it. Anyway, so one thing you should actually take note of is when you're taking the capacitors out of the board is verify that the white stripe, the negative side, is lined up on every single capacitor. So basically what I mean by that is when you're taking them out, make sure you take note of which way they were orientated in the slot, because sometimes you'll find that as the manufacturer makes a board, he or she may have put the negative on the wrong side. So you've got to take it verbatim that the original person who installed, you know, the power supply parts did it correctly, because obviously the power supply was working. It's now not working. So this was, you know, inserted in that direction with a negative on the positive side, as it were. You better put it back in that way, even though, you know, the board will tell you it's negative. Now I just want to show you on the board. I'm going to take this one back out. So on the board here you've got your negative and your positive. The negative is indicated by the little, you know, white stripe that's in here. So brings it up to you there. So I'm hoping you can see that. There you are. So on the actual capacitor as well, you have a stripe which tells you. It's also the shorter leg. Longer leg is the positive. So basically what I've done is I just literally put that in there through the holes. This is why I want to do this live on camera. And then I just literally just bend it a little bit. And that's it. Now I'm going to basically solder them off camera again, because there's no point doing it on camera. So I took all the capacitors out, and as I was taking them all out, before I took them all out, I actually listed them out here on this sheet of paper. So I took a photograph of the actual board, I labelled each one, wrote down what each one was. I then kept all the capacitors to one side, as you can see here. Then what I did was I went and I got brand new capacitors, and I basically said, okay, that's that one, that's that one, that's that one. Every time I got a new capacitor, I put them over into my waste pile. So eventually I'd have a whole load of new capacitors, and then I counted the new capacitors, I counted the old capacitors, and then I verified that I had the exact ones again, just to do a second time, and then I started putting them back into the board, as you can see here. Now they're back in the board, just, you know, sitting in place. They're not actually, you know, soldered in place, but we will do that. We will solder them in place. So all I'll do is I will solder each one of these in place, and then I'll cut the leads off the end of them, because you obviously don't want these bits dangling off, and then we plug it in, and hopefully the power supply should work without any issues. The only thing I'm concerned about is this fella here, because of some of the wording. I couldn't find out the exact wording on what was going on. Like this particular one that was in it, you know, mentions negative black. I couldn't figure out what that meant exactly, so I just basically matched up negative to negative, as was told. That basically was in that way, so I did the same thing. I'm presuming that's what it's talking about. Negative is black, because black is usually negative. I just don't know. Maybe it's just a terminology that Nippon use. You know, I'm not actually too sure. And like I said, I couldn't find the information. So anyway, hopefully when I plug this in, it won't go kaboom. I'll put it this way, this video you will never see if it goes kaboom, because I won't upload it. So it's as simple as that. Anyway, so yeah, just to summarise again, so basically took everyone out using the soldering iron, and I then put all those capacitors to one side. I then took out my new capacitors, I then matched them all up, I counted what I had, and then I put them back into places where they went. But one of the most important things to do, don't worry about this number over here, that's, oh, there goes one on the floor. One of the most important things to do is to take a photograph of the board. That way it's easier to figure out what's what. You can also, you know, download the schematics, because these particular Laserdisc boards will be fairly common. What I'm also hoping is, although I did quickly look back on my old video, this board I don't think is in the higher end machines. It's definitely not in the CLD-925, because CLD-925 has a switch on this side here somewhere. The CLD-925 is the UK NTSC PAL Laserdisc player. Basically there's a switch on the front of the machine, which is an actual power switch, like the old style AT power supplies that you'd have in the old style PCs. Whereas this is what's known as a soft power on, so a bit like an ATX type power supply, where the button on the front is only, you know, 12 volts or whatever the hell. I don't know exactly what it is voltage wise, but let's say it's 12 volts, so it's powering on the thing soft, so it's telling this power supply to turn on. Whereas the old style one that's on the AT power supplies, or the style that's on the 925, is a hard power on. So basically what you have is the 220 volt switch in and around this location here. There's a big button on the front of the 925, a big bar goes along and turns on and off the switch. We will be revisiting the 925, because I've ordered a laser to fix my 925, which is not working. I actually have 3 925s, would you believe? So we'll take apart one of them, and we'll have a look inside it. But again, the 925 is very similar to the CLD-390 and the 590. The only difference will be that hard power on switch, which actually, you know, engages 220 volts. What else is there to look at? The board itself, is it worth looking at anything else on it? Yeah, it probably is. I tested a few of the capacitors randomly with a tester, and the rest of them seem to be fine, seem to be within the tolerances that are labelled on them. So there's not much I can do. Like I said, the most common capacitor fault on here would be these type of vented capacitors. They're the most common ones to dry out. I did see a little bit of liquid underneath this one, underneath these two here, and a little bit of a smear on this one was all drying out. This, it wasn't actually wet. So this one, and this one had smearing under it. I wasn't going to take this one off originally, but I decided I might as well, since I had it in stock. And like I said, I'm not too sure whether it's in right. It is in right insofar as negative is to negative, but like I said, this negative black thing has kind of got me, threw me for the curve. Anyway, that's the snapping capacitor. It's already soldered in, or soldered in if you're American. So it's done. I will solder in the rest of them. I will cut off the leads. I'll show you a bit of my soldering on the bottom, how I'm doing it, and I'll get back to you on this. So right, let's get on to soldering, or soldering if you're American. This capacitor here says it is 100 microfarad. Okay, is it though? This is the question. Let's find out. That's testing itself there. Okay, so let's see. Let's see how much is lost. 90. Now this is one of the capacitors I took out of the machine, out of the laser drive. Let's have a look. 1540. That should be 2200. $1285 should be 2,200. And 2,100, and it should be 2,200. That one's not too far out. That's probably still okay. But it's best not to use it. Best to change them all, because you'll put a strain on any capacitor that's still in there. That's why it's best to change them all. 331. That should be 470, I think. Yep, should have been 470. Now I know it's flattened, but I flattened it. I was studding it. Ah well. This one. $378. That should be 470 as well. Yep. This one here. Let's see what it is. Don't mind that. I slipped on it. No, that's damaged. So that one's gone. That one's actually dried up. Gone. So there's one capacitor actually gone. The brown capacitor was the one I suspected was as faulty at first. Turns out it's the best one, huh? But as I went through the system, I found another capacitor faulty. So I decided, look, just change the whole darn lot. It's best to change them all anyway at once. So you're not really saving anything by just changing the one. That's 360. It should be 470. Next one. Don't mind that. $82. That should be 100. $84. That should be 100. Oh wow, what's going on there? Oh, it's a nanofarad, yeah. 9696 nanofarad. That's not bad. That's not too bad actually. That's not too far off, in fairness. It should be 10. So that's breeding I presume that's nanofarad. I presume that's what the N is. Maybe it isn't. Maybe it's knickers. Right. UF, so 1049. So this one's okay actually as well. Yeah. Now there's an example there. Now see, now that's a good example. So that's reading 10. Okay, which is what it is 10. So that's above. So that's a good capacitor still. That's actually in good nick, that one. Okay. Okay, 10.3, good. And then this is his brother, I think. God, I hope I picked the right one up now after all that. No, I didn't. Where is his little brother? Oh, where can he be? It's a mystery. Ah, there he is, there he is, there he is. Okie dokie. Alright, let's try that again. One more time, and that's it, we'll leave it. So 10.34, 10.43 I should say. Again. Yeah, so that's slightly under. It's not too bad. They're actually, those two there are probably the least affected by the dry rot. What can also happen, you see, is just a pure heat inside the power supply can kill the capacitors. But anyway, they're all the capacitors there, just to show you again that we took out of that Laserdisc drive machine. And it's a fair old selection of them all either. So these are all going to go into the wee recycling bin. That's not an Irish term for a small recycling bin. That is a recycling bin for electronic waste. Okay, welcome back. I'm now going to try and put these little babies back on here. So man says, wish me luck. Try to heat the leg. hopefully get a nice flow going. Seems to be alright. May require more flux on that. Let's take a look at that. Yeah, it's not great. I'll try another one. Do this one here, see what it runs out like. See, you should get a nice flow like this here. That's what you're basically aiming for. So let's see now I can get it. That one there is okay, that one there isn't. That one's okay, that one's not great. I'll have another look in a second now. I'll heat the leg up a bit. See if we can get it in there better. That's better here. I said I probably could do it more flux going on down there. This is a lead solder, in case you're wondering. All that lovely smoke fume is lead solder blowing off into the air. I have a very silent fan operating above my bench here. You may be able to just hear it. I'm very quiet. So I should be taking it away, and I'm not hovering over the top of the board either. But nowadays we'd have lead-free solder. It's not too bad. Man says it might work. Then again, it might not. There's only one way to find out. Okay, so here's our board. Hopefully we've got it right. So that's the before picture, and now there's our after picture. So yeah, I think we're good to go. So what I'm going to do now is I'm going to grab the player. I'm going to stick this back into it. I'm going to plug it in, turn it on, and see if we have a loud bang or if the machine actually turns on. So fingers crossed. Okay, so we've replaced the capacitors, and that's all we've replaced. We replaced the main one coming in, replaced all these beauties here, and the small little fellas. All the capacitors have been changed on this. I've reattached the cable. So that's all I've done is reattach the power cable from the power supply unit board to the actual controller of the laser drive, where all the electronics are that operate everything. So I've got nothing else connected. I haven't got the laser optical drive cable connected or anything like that. So what we're going to do now is we're going to basically plug it in for the first time and see if well, it's not really factory installed smoke in this case, but we're going to say the factory installed smoke gets released, or whether we've actually solved our problem. Like I said, the most common fault on these would be these capacitors. I've actually tested a few of these, older ones that are in here, and they should be reading, 2,200 microfarts, and they're not. They're about 1,200 and 1,600. Strangely enough, this one here isn't too far out of whack. It's 2,200. It's about 2,156, so it's actually not too far out. The rest of them are miles out. The big fella, the bruiser, he is reading a 700. He's reading about 92. Instead of the 100 that's written on it. So they've all lost some of their capacitance, and basically they dry out over time. Like I said, they're the most common fault on any power supply board, basically. If in doubt, take these babies out and put new ones in and see the power supply works again. If it does, you've solved your problem. Just a quick recap. As it was taken, just realised I made a pun there. Just a quick recap. Oh God, that's a terrible joke. That was really, really bad. It's like the one I heard recently. I was having a long chat with a spider. Turns out he's a web designer. Yeah, it's that level of silly humour. Anyway, the recap would be, when I took out the old capacitors, I verified which side was minus and which was negative. In other words, the stripe on the side, I checked it out and made sure that when I took one out, that's the way I put the new one in. you can find sometimes that the boards are, you know, they might say one thing, but the capacitor put it in a different direction. So basically, if they come out that way, put them back in that way, and don't necessarily rely on the board itself to give you the correct instructions. The schematic, if you didn't take a photograph of it, as we mentioned already, the schematic might help you out, but it's best to have a look at what way they were already in and just replace them exactly the same way, because sometimes it does happen where the capacitors are actually put in the other way around. The screen print on the board has been put in incorrectly, so wherever way it came out, put it back in the same way, and you should be absolutely gold. Okay, so we're going to now plug it in, and let's see if we get any action. You won't be able to see the front of it because I have that obviously off camera, so I'm actually going to need that screwdriver there, because this is the one that wasn't working from the French fella. So we're going to see now if it comes on or if it just does absolutely sodding on. Okay, now we're on, we've got power. Everybody stand back. Yes. Yes, yes, we have life. We definitely have life. Okay, I'm just going to pause the camera there for a second and bring it to the front just to show you. So please bear with me. Okay, so we have the power light. So we're now going to turn it on. There we are. Now the problem it's going to have here is it's not going to be able to do sod all because the drive tray is missing and the laser assembly hasn't got the power to it. So it's going to give you an error. If it can't move that laser, it's going to give you an error straight away. So we're going to have to connect that cable in. The problem is at the moment is I just basically put the cable from the power supply board directly into the system board just to see if I could get the thing working. I took the cable out the last day, so I'm going to see now if I can feed that back in without taking the whole assembly apart. So come back to me in just a moment and we will continue. Okay, so I'm going to turn it back on again now. So we have life, we do. Okay, so now we're going to see if this drive drawer goes in and attempts to read a laser disc. There we go. Try to read a laser, which it obviously can't. That's fine, let's just get it to eject. Oh, now there's a problem. It's obviously orientated wrong there. Yeah, it's ejecting the wrong thing, which is interesting. Well, anyway, we have managed to get it running again, so that's at least something. But the next thing we're going to have to figure out is the plate is ejecting only the center part. See, watch. Even when you press the laser. So as far as I remember, I know I noticed something one before. The arm in here seemed to make a difference to that. So I'm gonna have a look at that now, see if we can solve that problem. But so far so good. Where it's going off now. Let's see if it goes off. That's it. It's off. So join me in a moment. Okay, so welcome back. Yeah, this arm here you see is what actually dictates whether you're playing a CD or whether you're playing a laser disc. It'll actually tell the machine to take out the middle tray or take out the larger tray. So what happened was this power supply cable here basically was riding too high and it was stopping this from coming out and stopped it from moving basically. So that's what caused the problem. Anyway, so that's the end of the video. I hope you enjoyed it. Like I said, I didn't want to bore you with my soldering or soldering, but again, a quick brief history of what happened. I'm not going to use the other word. Is that we went ahead and we tested the capacitors on this board. One interesting thing actually is that this capacitor here I tested and it would always come up as a failure. Even when I tested it from underneath, it would be failing it. So I took it out anyway, but when I took the actual capacitor out of there, which is this one here, it turned out to be the least faulty. It was actually within tolerance, this one still, and the rest of them are gone. So again, take out all the capacitors, verify which side is negative, which is positive, take a note of them, take a photograph of the board first, write down on your photograph what's going on. what part is what. Just going to quickly grab that sheet again, in case you've forgotten in the past few minutes. So there's a photograph of the original board. So that's the original board there. That was, God, you can't even see it. Hold on, let me just zoom out for a second. You don't see half the workbench now, but sure. There's a lot of stuff in the way. So yeah, so there's the, still can't see it. So there's the original board with the original capacitors in place. So they were all taken out and replaced with nice shiny new ones. One of the warnings that I'll probably have to give at the start of this video is that don't play with the power supply unless you know what you're doing, and be very careful with, you know, this capacitor here especially. It contains a lot of voltage, so make sure you discharge it before you go playing around with the actual, you know, taking that capacitor off of there. That's the capacitor that was there, this bruiser here. So there's a fair whack of voltage in that. It's enough to make your hair stand on end if nothing else. So yeah, so make a list of all the capacitors, verify the orientation. In other words, put them back in the exact same way as they came out, and you should be okay. So replace them all with brand new ones. Again, what I did was I had all the old ones and I matched up all the new ones. So basically I took out from my part bags a new capacitor, placed it beside the old capacitor. Okay, so then I knew then I had one of each one that I took out. I then got rid of all the old ones to one side. I then went through it again then and started to feed them into the board, as you saw in one of the videos there. And once that was done, then I went around and verified it for the second time. So the old adage of think twice, cut once. And then I started to solder them back in. Once they were soldered in from the rear and that was done and dusted, I then went ahead then and cut the extra bit of lead off the end of them. And that was that. And like I said, I plugged it in. Just be wary of the orientation of these cables. They're basically only going one way. Well, say going way, you can put them in both directions, but one direction there's no contacts, the other direction there are contacts. So you want to make sure that you put it in the right way, otherwise nothing will happen. It'll just sit there like nothing will happen. So power supply is recapped, so that's a good power supply now that'll work in a few other devices that I have. I've never recapped any of the other machines that I have. I've never had any need to, but yeah, it might be something I might want to look into in the future. But you know, it's one of those things where it's not broke, you don't fix it. One thing I will suggest with any of these old machines, whether it be this or a VHS machine, is turn the machine on, use it, run a disc through it, that sort of stuff. It's definitely worthwhile doing that, just to keep it limbered up and working. As for the laser that's in here, we've visited this one before. See, it's gone stiff. See that? So there's no movement out of that whatsoever. That should be free moving in there, and it isn't. When I move it to one direction, it stays there. See? So it's staying there. That should be free moving in there. So that laser is what's known as FECT. Okay. What I did try once was actually try to change the faulty laser. Well, that's just this is that one actually, where I tried to change over the faulty laser, but it didn't work. It just made no difference. It still didn't work. As one guy said, I broke one from them. No, they're both broken. They both had faults. The other one had a piece sheared off the back, which I couldn't solder back on. So I basically replaced this top part, which is a non-replaceable serviceable part. So I replaced this top part, and I still had no joy. I'd say it was done properly, and this had to be in, you know, a part that was working. I'd say it probably would have worked. You know, maybe it wouldn't have, but you know, I'd say it would have stood a better chance if we were able to sort of solder those small components. It's just very hard to do that. So yeah, I tried and I failed, but at least I tried. Anyway, you'll notice here now it's trying to read a disc, see, and it's doing nothing, see? That should be, you know, bobbing up and down, and it's not, it's doing nothing, see? So if I put a disc in there, it's going to say no disc, because it just physically can't read it. It can't focus its beam of light on the disc. So the light comes out of here, hits the disc, and comes back down again and is read through this, okay? So that's it. I'd like to say thank you very much for watching my videos, and please like and subscribe as always. And if I come across any more interesting stuff to repair, of course I'll do my best to repair it. But laser drives are one of those things that is a rare beast on YouTube, so it's one of the very few videos that I can actually put up on YouTube that people can watch and enjoy. So yeah, I hope to go back to some PC stuff soon, but until next time, thanks, goodbye.